Okay, so now that we have the basics of probability down, let's look at how we can use some of that information to solve some different problems we have. So the first rule we're going to look at in regards to probability is the complement rule. So the complement of an event is the probability that the event does not happen. So the probability of any event A and the complement of that event A sum to 1. So when we look at the notation, we can find the probability of A complement, so this means the complement. You might also see it written as A with an apostrophe, can be found by taking 1 minus the probability of A. Or if we look at a picture of this entire box here represents the sample space of my experiment, whatever it might be. What I have circled with the A inside, that's the outcomes of the event that I'm interested in. So anything outside that circle, but still in the sample space, is the complement. So if my event A is that I want to roll a 2 on a die, if I could spell the word roll, apparently. The only outcome in A is 2. A complement would be any other outcome that is possible. So a complement would be I roll a 1, a 3, a 4, a 5, or a 6. And combined, I have all the possible outcomes in my sample space. So let's look at another example. If there is a 25% probability of snow tomorrow, what is the probability that it does not snow? So here we have a keyword, does not snow. Whenever we see the word not in a problem, that means we want to find the complement, the probability that the event does not happen. So the probability that it does not snow is the complement of the probability that it does snow. So I can find this by taking 1 minus the probability of snow. The probability that it snows tomorrow is 25%. We want to make sure we take any percentage that we're given in a problem and turn it into the decimal equivalent. So 1 minus 0.25, which is 0.75. So the probability that it does not snow tomorrow is 0.75. Or there is a 75% probability that it does not snow tomorrow. There's one way that we can use the complement rule. Let's look at another. So here we have the results of a probability experiment. The table shows the color Skittle from a bag of Skittles and the probability of getting each color. But we're missing the probability of a red Skittle. So if we recall back to those two very, very important rules, the second rule was that all of the probabilities for the outcomes of an experiment have to sum to 1. So here we have all of the possible colors we could get in a bag of Skittles. So all of these together, the probabilities of green, red, orange, yellow, and purple, those have to sum to 1. So I can use that information to find the probability of drawing a red Skittle. So the probability of a red Skittle, I'm going to use kind of a flip on the complement rule, is 1 minus the probability that I draw not a red Skittle, meaning any other color but red. So I need to first find the probability that I don't get a red Skittle. So the probability of a not red Skittle is going to be the probability of a green Skittle plus the probability of an orange Skittle plus the probability of yellow plus the probability of purple, because those are all of the Skittles that are not red. So I'm going to add all of those up, and I get 0.82 for the probability that I don't get a red Skittle. So then the probability that I do get a red Skittle is 1 minus the probability that I don't get red, which would be 0.18. So the probability of getting a red Skittle out of a bag of Skittles is 0.18. So we used a little bit of a variation of the complement rule there to find the missing probability from our table. So this is the complement rule. We're going to use it a lot, so make sure you understand it, and we'll move on to the next rule.